This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 104, a look forward into 2022 and news and events from the Ansys world. Welcome back to our podcast and to 2022. I hope everyone that has holidays around the new year was able to get some time off and hopefully spend some time with friends and family. COVID-19 and specifically Omicron hit Arizona pretty hard, and although it was a good break, many of us had to spend a lot of it isolated, unfortunately. But we're back now, getting settled into 2022. It's been a fast start with our Ansys team especially busy right out of the gate, which is good to see. If parts of your New Year resolution was to look for something new in your career, we're hiring in multiple positions, including Ansys-related positions. We're growing our Ansys sales team across the southwestern U.S., so if you know somebody that's interested in being a salesperson for Ansys, please have them check it out. We also have openings for an application engineer for Flownex, as well as looking for engineers who know embedded systems programming, optics simulation, and structural simulation. So if any of those are exciting or you know somebody that might be interested in those, visit our career page at www.padtinc.com for those openings and several others. So we usually start the new year off on this podcast with a group discussion on what to expect in the coming 12 months, and 2022 is no exception. Please do take a listen to what the team is excited about. Well, welcome back and Happy New Year to everybody. We're here having our traditional beginning of the year discussion about what we're excited about in 2022. I don't know about the rest of you, and we're recording this in the middle of a major peak in Omicron. It's been a rough start to 2022, but not so much in the Ansys world, I think. So hopefully, I want to welcome all you guys, and hopefully you had a good break and that the new year is treating you well. I'm just going to go ahead and call around the room so you can introduce yourselves, and we'll start with Alexander Gavarov.
Hello, everyone. This is Alexander. I'm double E location engineering, and I'm basically responsible for anything to do with electronics. So HFSS, SI Wave, that's all me. I located in Denver.
Very good, very good. Glad you guys got some snow finally.
Yeah.
Alex.
Hey there, I'm Alex number 2, Alex Moody. I'm also an electrical engineer. I also am an application engineer, and I also work in the high frequency electronics area. I'm located in Tennessee.
Great. And by the way, if you go on our website, you'll notice that we are always hiring folks, and we are hiring for electrical type people like the two Alexes. Your name does not have to be Alex to apply. We'll take anybody. Doesn't have to be Alex. Josh.
Hey everyone, so this is Josh. I am a systems engineer, application and support here at PADT. I'm in Mesa, actually very close to PADT HQ, so I'm enjoying the weather right now.
Yeah, it was gorgeous yesterday. Yep. Miles.
Hey, my name is Miles Atkins. I am also in the Phoenix area. My expertise is also in systems engineering, primarily looking at fluid networks. And my tool of choice that I typically am working with is Flownex, although I also play around with coupling these system tools with Ansys products, Ansys Mechanical, Ansys Fluent, etc.
Great. And then Robert in Texas.
Hey, this is Rob McCatherine. I'm a structural engineer and application engineer with PADT. Been around here for almost 4 years now. And
wow.
Time's flying.
Time flying.
And doing good down here in Tomball, Texas, right outside of Houston.
Very good, very good. And Mr. Chadwick.
This is Tom Chadwick. I'm one of the CFD support engineers, also work with some of the system stuff, RSM, things like that. And I'm here in Arizona, been working for PADT coming up on 8 years now.
Wow. Yeah, the time dilation in the last 2 years is crazy because I would have said 2 years for you for Rob and 6 years for you. So I think I just
Yeah.
lost 2 years.
Yeah, we've all just lost 2 years of our lives here.
Just Rip Van Winkle through it all.
Exactly right. Exactly right. Well, the reason why we're gathered here is that both Ansys and Flonex have new releases coming out soon, and we wanted to spend a little bit of time to get people excited about it. The releases have not failed to to have good stuff in them. It's everyone. There's two a year now, and everyone has had some great stuff in it and all the different products. So I thought it would be great to just sit around and talk about that. So I'm gonna go ahead and give Flonex a little bit of love and let Miles talk first. Because there's some cool stuff coming there, and we always think of them. We always think of Flonex second. So I'm going to put you first this time, Miles. So what's coming down the pipe that people need to be excited about?
Sounds good. So I guess I don't know that I can specifically give any details to the new release.
Right.
It is tentatively planned to come out, I believe, towards the end of this January.
Right.
But it's really cool to see the collaboration between Flonex and Ansys. Flonex is now a technology partner with Ansys, so those couplings are only getting stronger between the two tools, as well as Flonex just becoming more and more capable as a 1D fluid network solver. So really exciting to see more adoption and that collaborative interface between the different sets of tools.
Yeah, I think it's accurate to say that we're seeing more and more customers who have maybe an older or an in-house 1D code that they've been using for decades sometimes to couple with their CFD or to do quick simulation, and they're all kind of looking at Flonex to have a more modern tool. You kind of saw that last year, right? Quite a bit.
Absolutely, and where Flonex really excels is when we're replacing Excel spreadsheets that are 10 years old and nobody quite knows how they work. So it's very handy to take in a commercial off-the-shelf software that is easy to use and has all the physics capabilities that you would expect.
And keep all those correlations, which is why those spreadsheets are so loved, and stick them into a modern tool. Yeah,
absolutely. Yep.
Yeah, cool. Well, let's talk about HFSS. Because I always feel I'm biased as a structural person. I always start with Ansys Mechanical, so I'm going backwards this time. So HFSS, the electronics packages. What's the goal for these upcoming releases there? And I'll let either Alex answer that question.
Well, I guess I'll just go start. Probably do some cherry picking to make life a little more difficult for Alex. No, but yeah, overall, usually every release for HFSS, it means more accurate models in results and more, I guess, less time consumption for solving and everything. So we're always trying to optimize the engine of the solver. And trying to tackle more and more complicated structures to make them more accurate in this case, because sometimes you look at them years ago and there's some structures which you still had some problems with, but not anymore, right? So it's every year you get some upgrade in that direction. So and then also there's also some other features which kind of optimizes the mesh, for example. So and then allows to do some other techniques. From what I remember, just off the top of my head, actually, in the 3D layout, so they have this new capability which came from last year, from last release, is a fee measure, and so now it's really getting up to speed in that direction too. So now it's more enhanced. So technically what's good for is that for complicated structures was 3D. So let's say ICs, for example, when you have bond wires, when you have some 3D structures in there, stacked different components in there. So yeah, I think HFSS is also trying to explore this new frontier of getting into close to semiconductor business, right? So because we have different tools. And I was about to say semiconductor, but I don't think that's the. So yeah, so I think it's trying to fix that gap. And from the different direction, you have optics, right? So they're coming
Right.
from different direction. So that's a higher frequencies, and I'm pretty sure HFSS will be also trying to, fix that gap as well on that side. So yeah, so it's basically trying to get better, and better every release.
Good. Alex, anything you want to add to that list?
Alexander hit most of the big ones. The Phi Plus technology is the one that I would have mentioned, but in addition to that, just maybe a smaller little tweak to HFSS, the shooting bouncing ray SBR Plus has a new surface roughness model for the automotive radar. So as you know, when a radar hits a smooth surface versus a rough surface, there's gonna be a big difference in the returns. And so now HFSS takes that into account, which is for those who are in the automotive industry who are doing automotive radar, that could be a big deal.
Yeah, very big deal. Oh, that's good to know. That's a lot of work in that area, and it just keeps improving. And Alex Leander brought up the optics stuff, and we hope to learn more about the ZMAX integration, but even outside of that, all the different optics packages are adding more and more stuff. And I don't know, are any of you following that, or is that somebody that couldn't make the call today? I can't. Josh, are you paying attention to the optics stuff?
Not really.
Not really.
I've had to sit in a few calls.
By the way, for those listening, that is one of our job openings. If you know an optics engineer that's interested, I'm watching the email traffic, and there's just a lot of good stuff going on in photonics and even at the quantum simulation level. So it's pretty exciting to see that and get integrated into the Ansys family to do multi-physics around devices that have optics and photonics in them. So I'm pretty excited about what we'll see. I think it'll be a big year, I think, for optics announcements. So I'll pick on you, Josh, since I already picked on you. Saw more users adopt Sherlock this past in 2021. Anything exciting coming down the pipe from them? Or more integration with Ansys? Is that other Ansys products? Is that where they're focused?
Yeah, I would definitely expect more integration. I'll admit you've caught me a little bit flat-footed on Sherlock since I haven't been able to make the update presentation.
Okay.
Yeah, I mean, it's just kind of common theme from release to release is they keep making things easier and easier to access and better documented and yeah.
Better integrated, better documented, faster, better geometry handling.
Yep.
And we'll put our usual appeal out there. If you work with any kind of electronic packaging and you're not using Sherlock for your reliability simulation, you need to be taking a look at it.
Right. And I wouldn't be surprised at all if, now that they have the skeleton for Sherlock pretty well defined, they will probably continue to add new packages, new geometry definitions, things like that.
Good.
So it's pretty easy to keep adding on to it and just make it better all around.
Good. What about the IcePack products? Anything exciting coming down that road?
Pretty much the same theme. Kind of what I was sort of expecting for this year, which I guess we'll wait to see if it happens or not, is I'm expecting a lot more growth on the battery side of things.
Okay.
So as far as electromechanical, electrothermal, electrochemical, all of that, that's been well supported by Fluent so far. And they've been moving that over to IcePack a little bit.
Okay.
But I wouldn't be surprised if there's more battery stuff, specifically coming down the line, in both IcePack and Fluent. So I look forward to hearing more about that, yes or no, for sure.
Yeah. Everybody. I was telling some of my friends who aren't engineers who are all excited about all the electric vehicles coming out and saying, somewhere there's a group of engineers who are kind of pulling on their beards, going, how in the heck are we going to fit this in this car? And how are we going to keep it cool? And how are we going to make it last? And simulation, of course, is the way that we figure it out.
Yeah, it can be a tough problem these days.
Yeah.
It's really important.
Yeah, definitely. Any other products you're following, Josh, that you want to mention?
Probably another big one is OptiSling.
Okay.
And again, I'm kind of a broken record here. They keep making it better to use, easier to use all around. I know they're adding some new buttons for like one-click optimization where they had wizards in the past that would kind of guide you through all the steps that I thought were great, but I mean you still have to be fairly familiar with the tool to customize them and make full use of them. So they're streamlining that even further down at this point. So it'll be interesting to see how well that works and how many people are interested in using it.
Yeah, the thing I'm seeing in the OptiSlang world, which is exciting, is the large enterprise customers. They've had it and now they've been using it for a while, and that's driving a lot of this improvement for the tool and connection to other Ansys products. So these big companies that have every Ansys product under the sun are using OptiSlang to kind of corral it all and optimize with them all, and it really seems to be driving the developers to making it more usable and more capable and more applications. So I'm excited about that.
Yep.
Yeah, it's good. It's good. Optimization is always needed. So CFD, Tom, what's coming down the road in that area?
So there's a couple things that I've been really interested in wanting to try out. Fluent, they're starting to add in some custom workflows. They've got external aerodynamics workflows where it's streamlined, so you can actually do things like put in angle of attack, free stream Mach number variations, and do design studies on those things. Not only angle of attack, but angle of yaw, things like that. There's also one for, and this is kind of particular to aerospace and some other specialized applications, but there's an icing workflow.
Oh,
so
great.
For things like wing icing, pitot tube icing, so pressure sensors, the sensors, external sensors on aircraft historically have had problems that at certain conditions they can get iced over and stop reading correctly. And so it's a big deal for the aircraft industry to be able to accurately model that and predict when icing is going to occur, not only in the wings and stuff like that, but in the fan inlets and stuff like that, because it can actually damage the engine of the plane if you get a large sheet of ice built up on the intake, and then that sheet of ice separates off and gets sucked into the engine. It can cause damage. So predicting when the ice is going to form, how thick it's going to be, how it's going to change the vehicle and all that, that's all being worked extensively.
Good. And that's in Fluent.
That's in Fluent.
Great. What's the name of the solver that they acquired? That's the core of that?
It's FenSap.
FenSap. Yeah, FenSap.
Yeah.
So it's great to see that integration. Yeah.
Yeah. So they're really working hard to integrate that in. They're working a lot with NASA and with the other, the academic world. Great. Making sure they have accurate models for that kind of stuff. And one of the other interesting things that I saw in a presentation about the new release is that they're working to integrate Python scripting.
Oh, good. So it's making it over there.
Okay. Yes, so that you can actually custom script interfaces and workflows into the Fluent interface, and customers that have a custom workflow can, if they've got the programming expertise, can build their own custom workflow.
So this is like the PyAnsys, and I forget the other.
It's actually I think they're actually calling it PyFluent.
PyFluent. Okay, I don't have my head around the naming convention they're using, but it starts with PY and then they pick something else. But so we've seen this in some of the other products that already had good APIs where they're putting this Python and it's open. So we talked about this before in the podcast. It's open source. Python. It's not a proprietary Python like we were using before with IronPython. So pretty powerful stuff, and we'll definitely try and get Joe Woodward on at some point in the next couple of months to talk more about this effort, because I think it's going to be a game changer, because it's not just mechanical anymore, right?
Yeah, it's the whole
electronic desktop. It's everywhere. Yeah,
right. The whole suite of programs they're trying to incorporate Python into it, I think.
That's kind of cool. That's kind of cool.
And then, of course, the other thing is that they're, as everybody else has been stating, they're continuing to work on improving the robustness of the Fluent mesher, making it better in parallel. If I remember correctly, they're actually working to incorporate the GPU acceleration into
excellent.
the meshing.
Not that we can get GPUs, because all of the
cryptocurrency
cryptocurrency miners are buying them all. But if you happen to find one, you turn off your Bitcoin mine long enough to use it. That's funny.
But yeah, so I mean, there's just a lot of stuff that they've been doing with Fluent to improve it, and CFX, the other flagship software tool. Yeah.
Good. Well, we look forward to learning more about the details in those. Just great improvements. And then, last but not usually first, Robert, what's going on in the world of mechanical?
Yeah, so mechanical's been seeing a lot of, I kind of think of it as like quality of life updates with pretty much everywhere throughout mechanical. It's just been one of these situations where in the past I've been trying to do something with a nonlinear analysis, and I gotta I've got to my P's and Q's here, and then I won't do it in a new one, and all of a sudden it works. And I'm like, okay, well, evidently we're a lot more stable with that. And I keep on finding that with with customers too. I'm like advising them, hey, do this and this and this, and it's like, oh, it worked without that. I'm like, well, that's great. So
wonderful.
it's one of these things there's a laundry list of these things, whether it's ranging from solver times to nonlinear stability to adding more damping in different types of joints and adding stability for off diagonal stuff. It's that there's a whole big list of things, and otherwise they're still going through, like you mentioned, with the scripting and moving forward with Python and doing PyAnsys. Like that's still kind of number one on their hit list right there. They're rocking and rolling on that one, as well as the other features they've introduced into mechanical over the past couple of versions, with changing what were mesh connections to be more like batch connections kind of things, and having that on down the way, and mixing that with the welding capabilities, that the weld modeling capabilities they've introduced within the past two versions that was previously an extension. So everything's starting to flow the right way. And additionally, with other products that kind of mechanical adjacent, so stuff like Aqua. Aqua kind of suffered from still having the lots of little programs that are still attached to it, and now they are baking that in. There's like 3 devs for Aqua, so thank you, those 3, 4, 5 guys. So
hardworking people,
hardworking to get all that the old stuff and cram it in, and also have that available for Python scripting on down the way. Okay. Another thing I want to mention is Discovery. So Discovery is seeing more of the capabilities that were within AIM being reintroduced into Discovery. Okay. So stuff like beams and shells made it in this time. So you've got beam catalogs that were similar to what shape catalogs that were similar to what SpaceClaim had previously. That's in. Haven't gotten too much time to toy around with that, but I'm plan to rectify that early this week. Good. And then, as well as some other features, like Ansys has promised that the polyflow features that were within AIM before will make their way into Discovery, and it's not this release, but they're hoping it for next release. So that's going to be a big one for people that did use AIM and are transitioning to Discovery.
And polyflow is a tool that is really critical. For those that don't know, polyflow is a thermal, I always get it wrong, thermoplastic or thermal set or thermal, I forget, but it's for blow molding and extruding of plastics.
Right.
Let's just say that it's an old Fluent tool that had an antiquated interface. So they put it in AIM, which was a huge giant leap forward. So when AIM kind of went away, and people still can use it in AIM, but now getting it into the new Discovery interface is going to be huge for those folks.
Yeah, it'll be big.
Yeah, it'll be really, really big. That's exciting. So I did want to cover Discovery. One thing I wanted to ask you guys that I've struggled with, it's really not on topic, but I still struggle with it, so I thought I'd bring it up while you got all of you here, is what's the naming convention in Discovery? So Space Claim, what is that called now?
Well, it's been changed over the years. So
Yes.
it's one of these things where, Space Claim is still around. It's going to be hanging on for the next several versions. I think Ansys has a plan to kind of phase it out over the next couple of years. But Space Claim is still, it's like Ansys had a version of Space Claim, and the Space Claim Corporation has their version of Space Claim. So this is why Ansys is kind of differentiating that from a marketing standpoint, has been mulling around with the name Discovery. So eventually it's just going to be Discovery. So,
and that's the solid modeler and the simulation tools?
Correct. So there's just, 3 flavors of it, because there's the 3 tabs within Discovery. So you have, Model, Explore, Refine. And so that's going to be, the model mode is just the base level of Discovery. So, and the thing is that version of Space Claim that we're all used to is baked into Discovery. So Discovery is kind of stacked on top. So
Right. So no features are going away. It's a naming thing that I've been struggling with. Yeah.
Yeah, exactly. And it's been one of the things the Ansys marketing team has loved to play with over the past 2 or 3 years.
Yeah. So, but don't worry, nothing's going away. But yeah, I that came up in my head when you were talking about it, because it's been puzzling me for a while here. So that's good to know. Good to know. Did we miss any products anybody wants to bring up, or any features in some of the products we talked about that anybody wants to bring up?
I can just bring one more in our EBU side of space. So there's a EMA 3D solution, I guess we can call it. So it's not like a Ansys product, but it's still we're still responsible, and so we still can sell it. So EMA 3D cable. So now we also have a new tool in there. It's called EMA 3D charge. So what it does is basically allows you to calculate electrical discharge. So usually applicable for aircrafts and planes in the sky. So something which can be hit by strike by lightning, for example. And so what you'll do there is basically you attach the location of the lightning and see how it's gonna behave in your object, right? So for example, if you're in aerospace, you're shooting the satellite out there in a low orbit, for example, and somehow gets those lightning strikes, which goes out, for example. So and then you can probably model that and see how that's gonna react on the lightning. So that's something new and actually really exciting, to be honest, because I haven't seen any other tools like that. And from what I know, there is low competition in that area. So high demand, low competition, success. That's it.
Yeah, really exciting. And it's funny because that's one of those questions that I used to dread getting when I did what you guys do now from customers. Can you guys model what the current is in my wiring harness if I get hit by lightning? And we would just look at them and go, no, you can't do that. Now we can.
Yeah.
So yeah, that's pretty cool. Coming a long way. I will follow up with all you guys as the products come out and talk about once you had a chance to use them and things like that, and plan this year to do a couple deep dives into some of these products as well to kind of understand all the capabilities and features there that people need to be aware of so they can be more efficient in their simulation. Any closing remarks or thoughts for the 2022? Oh, good. No jokes? Okay.
Just looking to see what Ansys will buy this year in terms of optics again.
Yeah, I'm sure we'll see a purchase, and it's funny you brought up that I'm really hoping that they move into injection molding. The two big injection molding tool and simulation tools out there. One is owned by Autodesk, so I'm sure that's not really an option unless Autodesk wants to get rid of it. But there's some up and coming ones as well, and we integrate with all those. And I bring it up because we're seeing it on the design side of our business. We're seeing more and more people trying to use fiber-filled plastics. And so you use these tools to calculate what the fiber alignment is, and then import that into Ansys using that new field file format that they introduced about a year ago. And it's really cool. And it just got us thinking that it would just be really cool if this was an Ansys product and we wouldn't have to deal with another vendor. So we'll see how that goes. Hopefully it will.
Yeah, I think that's one of the things. I think that's one of the games we always play working with Ansys is acquisition bingo. Figure out what
any
they're going to
predictions from you,
require.
Tom? Anybody out there you think they'll buy?
Well, Miles.
I was about to say that too.
Flonex. I think that would be one of the things that they would.
Mm-hmm.
It would be interesting to see them do to incorporate it in and make it actually integrated more tightly with Fluent and just make it easier to run those kinds of things, because there are some things that Flonex can model really well that are difficult to do with Fluent without, especially the transient stuff, without making a really large complex model.
Yep.
So,
for sure.
Yeah. Although I like having Flonex to PADT.
Yeah.
Nice.
So what about CFD? I think that's still on the table.
I'm sorry, you cut off there.
CFD++. What do you think about them? Do you think that's still on the table? Not CFD++. Yeah, CFD++, the hypersonic tool. Yeah.
Oh, well, I think that just that they're doing so many improvements to Fluent to improve its hypersonics capability that I think it's just making us even more competitive.
Yeah, that less likely.
That's always been the one. We have some customers that specialize in hypersonic stuff, and that's always been a limitation where we say, Fluent has the capability to do it, but it's not really, it's difficult sometimes to get a converged solution easily with Fluent in that kind of speed regime. But with the changes that they've made, and in the last two or three releases, they've really focused on, they've got a team that's focused on making it simpler. And
hyper focused on it?
They're hyper focused. Yes, that's a good
bad pun.
So anyway, so I don't think that, in terms of other tools, I don't think that there's really any other CFD tools that they would.
Some small thing we haven't heard of before.
Yeah, that there might be some small niche tool. As you described, some of the blow molding stuff, there are some things with that would probably be good to, just to complement the capabilities. But
I wouldn't mind them adding a civil code. That I don't know. That's kind of your area, Rob. Not so much for the solver, because our solvers kind of blow all the civil solvers away, but the code checking that's built into those civil codes.
Yeah, absolutely. Like Ansys used to have a product that they inherited from the offshore industry to do a little bit of that, and then it'd be nice if it was just baked in versus third-party stuff. It'd be nice.
Yeah, it's for those that aren't familiar with it, it's in the civil industry, civil engineering, structural industry. They've got these standards that they simulate to, and it's kind of baked into those purpose-built civil engineering structural codes, to where instead of getting a stress level, you get these industry standard values out that they can use, and called code checking. Does it pass the code? And that would be nice to have. Definitely.
A lot of proportional stuff based on spans, unity checks, all sorts of stuff like that.
Yeah, that'd be good to have. Well, we'll see what happens. So far, the only thing we got right in a long time was Emacs, so we'll see what comes next. Well, thanks, guys. I really appreciate all your input, and always good catching up to you. And best wishes for 2022. Everybody stay safe out there, and we'll talk to each of you through the year.
All right. Thank you.
Sounds good.
Thanks,
That's
everybody.
great. Thanks, Eric.
Thanks.
Bye. All right. Well, I think a lot of good stuff is going to happen this year. So, when a new release of Ansys and Flownex are coming out, with all those coming out, we'll be holding webinars and deep dives here on the podcast. Make sure to subscribe to our newsletter so you know what is coming, or visit the events calendar on our website as we start having those things out, and we can do a deep dive into some of these products we just talked about. For our commercial today, it's the beginning of the new year, and it's a great time to set aside some time to evaluate your simulation needs. When was the last time you did a company-wide evaluation of what Ansys products you have? Maybe it's time to look at some of the newer tools that are even more integrated in the core products of Mechanical, Fluent, and HFSS. Motion, Rocky DEM, OptiSlang, Flownex. We talk about those tools on this podcast. Have you seen if they're a good fit for your company? Or maybe it's time to upgrade a couple of seats to full enterprise. And don't forget about Ansys Elastic Units, the easiest way to get access to other Ansys products and the Ansys Cloud. So regardless of where you are, reach out to your Ansys provider, which we hope is PADT, and set up some time to learn what is available and look at reconfiguring your licenses to get greater capability in 2022. All right, looking at news, there's not a lot. It's the beginning of the year, so not a lot out there. We'll take a look at the stock. So today I'm recording this on Sunday, January 16th. So we're already halfway through into the month of January. Looking back at the end of the year, Ansys stock finished the year at $401. It set an all-time high of $411 for a close on December 27th. And the following day, it set an all-time peak in the middle of trading at $413.89. So strong end to the year there. That 401 close was up 10.26% for the year. And that's not a bad return on investment at all. Although I have to point out that the S&P 500 went up 27.23. So the simulation stocks did not do as well as the overall S&P 500. In that group, Altair was the only one that was above the S&P 500. It was the biggest grower for the year in the category that we look at, and it was up 29.72%. PTC was up 2%, and Autodesk was actually down 7% for the year. So really, Altair was that only one that outperformed the S&P 500 last year. And it's Ansys stock is now down to $348.54. That's a $65 drop from that peak close of 401, and that's 16%. But year to date, with only 2 full weeks, so not much to really look at, the S&P is down 2% for year to date, and the Ansys stock is down quite a bit more at 13.1%. So we'll see what the year has to bring. I, as always, never pretend to understand why these things go up and down, but that's where they are today. There's no news out there from the Ansys folks, just some announcements of some projects they did with some customers, but no news worth reporting there. And same for PADT. We haven't had time to make any news so far this year. So turning to the Ansys blog, there's 3 articles that I think are worth checking out. The first is called Enabling Faster Ansys Discovery GPU Simulation on Ansys Cloud thanks to NVIDIA and Microsoft Azure. So this is about how they reconfigured some machines on Azure to take advantage of GPUs and the very fast GPU-based solvers in Ansys Discovery. So if you're interested in those things, cloud or computing or GPUs or the kind of solvers that Discovery uses, which run on GPUs, check out that article. It's got some good information in it. Another one that I really liked, because it was such a comprehensive example, was from about a French research institute called Supergrid, the Supergrid Institute. And the title of the article is called The Supergrid Institute Responds to Energy and Climate Demands Using Ansys Multiphysics Solutions. So it's a large organization that's using digital twins, using simulation, both very complicated down at the bottom and then high-level system level as digital twins to make a better power grid, basically. And of course, thermal management is important, but all sorts of other stuff. It's a great example because they're using SCADE for controls, they're using optimization, they're using mechanical, they're using Sherlock. There are all sorts of different tools are being used across the enterprise to come up with better electrical grids. It's a great example of multiphysics simulation with Ansys. And the last one I want to point out, because I like the title, is it's 5 p.m. on Friday. What is the status of your simulation project? We've all done that. We've all logged in and checked. Well, this article is about using Ansys Minerva to manage all those things, not just what your job status is, but to manage the whole project that you're doing using simulation. So if you haven't checked out Ansys Minerva, do check it out. It's a pretty cool tool. We really like it here at PADT, and we have finding more and more customers that find it useful as well. We didn't really publish anything other than some Flownex blogs since the last time we talked, but do check those out if you're a Flownex user. And upcoming events. We have one scheduled so far, which is Simulation Best Practices for Gas Turbine Design and Development. And that's going to be on Wednesday, January 26th at 11 o'clock Phoenix time, which is Mountain Standard Time right now. So if you're in the turbo machinery world, do check that out. That's a great event and be a good talk about all the different tools that are available. And as we discussed in the podcast, the interview for the podcast today, there's a lot going on in the turbo machinery world worth knowing about. No Ansys events that I'm aware of. And that pretty much brings us to the end of this first episode of 2022 of our podcast. We hope that everyone is safe and healthy out there and that things continue to get better in 2022. I want to thank everybody for listening as always. And don't forget to subscribe to our podcast, to our newsletter at www.padtinc.com/opt-in, and do subscribe to the podcast as well wherever you download your podcasts. Spread the word, let other folks know about it, and never hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 104. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.